All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you. And we're going to do another video on solving trig identities using Pythagorean identities. That's right, solving trig equations using Pythagorean identities. Here we go. Now, we've already taken a look at the mama one, right? The sine squared plus cosine squared equals 1. And now we're going to take a look at these other two identities down here. So go ahead, pause the video, because you'll see some different forms, right? Different forms of these on your substitutions that we're going to make. So Pythagorean identity number 2. 1 plus cotangent squared equals cosecant squared. That one, if you solve that for cotangent, that would give us the cotangent squared equals cosecant squared minus 1. However, if we were to solve that Pythagorean identity for 1, we would end up with the third version of that identity. And looking at Pythagorean identity number 3, same thing. There's two other versions of that. And those versions are going to be what we'll use when we do our substitutions, generally speaking. All right, so we've already done the sine and cosine one, so let's go ahead and take a look and get right into our Pythagorean identity number 2 when we're looking at example number 3 here. So here we go. We've got 3 plus cosecant theta plus cotangent squared theta. So one of the things you want to look at is the linear term. And remember, the linear term is going to be the one without an exponent that has a trig function. So that's my linear term. Now, my other term, cotangent squared, that's a quadratic term. So remember, we need to remember these types of terms so that we have these down. So that's quadratic term, and then there's 3 over here, that's just a constant. All right, now when we look at this and analyze this, we're going to take cotangent squared because we have a trig substitution for that. We're going to take cotangent squared and replace it with this cosecant squared minus 1, because notice that will line up with, it'll be the same as my linear term. I'll have my entire trig function now in terms of cosecant. So this would be 3 plus 3 cosecant theta plus, and then in cotangent's place we'd put cosecant squared theta and then minus 1 equals 0. So we'll have all of this, but then what we're going to do, of course, is we're going to rewrite everything in standard form. So that would be cosecant squared theta plus 3 cosecant theta. And then be careful here, you've got this 3 right here and a minus 1 over there. So 3 minus 1 gives us 2 equals 0. From here, now we're just going to simply work with factoring, our factoring skills. So that'll be cosecant theta plus 2 and cosecant theta plus 1 equals 0. And you can have those in either order, it doesn't matter, as long as you have those two factors there correct. And again, you could always double check to see if you factored correctly by distributing those, by multiplying those two binomials together or foiling them. Now, each one of these, then we're going to go ahead and solve independently. So cosecant theta plus 2 equals 0. That will give me this piece right here where I then have cosecant theta equals negative 2, which then leads to the reciprocal of cosecant, of course, which is sine. So sine theta, and then the reciprocal of negative 2 is negative 1/2, because remember, the sign stays the same. And then we look on our old buddy unit circles. Let me bring that guy in here. And most of you guys, I'm sure you have that memorized by now. So sine's y-coordinate. Where is the y-coordinate? Negative 1/2. So that would be down here in quadrant number 3, and then also over here in quadrant number 4. So those would be the two spots, and then we'd write down the two values. And we're going to write them in degrees and radians, so that would be in 210 degrees and also 330 degrees. And then their corresponding measurements in radians would be that 7 pi over 6 and 11 pi's over 6. So that's for that first factor. Again, it's up to you how you want to kind of go through and solve that. You could do each side one at a time. You could do it differently. You know, as long as you take your time and show each one of your steps, you are solid. So make sure you show this equals 0 line. So you got cosecant theta plus 1 equals 0, which is going to give us cosecant of theta equals negative 1. Now, what's really nice, when you do the reciprocal of negative 1, that's the same thing. So again, where's my sine coordinate, negative 1? All right, of course, theta would have a value, because sine is negative 1 at 270 degrees. So that's right down here, right there. And also the value of 3 pi's over 2. So those are the two spots where sine would be -1. So our three solutions for this problem are 7 pi over 6, 11 pi over 6, and 3 pi over 2 in radians. Now go ahead, hit pause, try the next one on your own. Go ahead and try example 4 on your own. Now let's come back and see how you did. Now we take a look at this problem. For those of you who want to go through it together, here we go. So cosecant squared plus cotangent. So my linear term is cotangent. My linear term is cotangent. So if that's my linear term, I'm going to substitute out cosecant squared. And cosecant squared, well, that's the actual Pythagorean identity itself. So we're going to substitute 1 plus cotangent squared in for cosecant squared. So 1 plus cotangent squared theta is going to be my value. That's going to get substituted in for the cosecant squared. Plus 2 cotangent theta equals 0. Now we're going to rewrite that in standard form, getting rid of our parentheses. So now we're going to have cotangent squared theta plus 2 cotangent theta plus 1 equals 0. Now this is actually, I don't know what happened there with the pain. This is actually a perfect square trinomial, right? So that's going to factor into cotangent theta plus 1. And then the same factor again, cotangent theta plus 1 equals 0. Since both of these are the same factor, we only have to do one of them, right? So cotangent theta plus 1 equals 0. Make sure you show that step. And then cotangent theta is going to have a value of -1, which means my tangent is going to have a value of the same thing because the reciprocal of -1 is itself. And then where's tangent -1 on the unit circle? And by golly, by George, that's going to show up here in quadrant number 2 at 135 degrees, and then over here in quadrant number 4 at 315 degrees. Notice they're 180 degrees apart. So that's kind of cool. So we've got our 135 degrees and we've got our 315 degrees, otherwise known as 3 pi's over 4 and 7 pi's over 4. All right, so that's it. That's these two guys right here working with Pythagorean identity number 2, 1 plus cotangent squared equals cosecant squared. All right, thank you guys for watching this one. Be sure you come back and check out the next one where we'll solve using that third Pythagorean identity, the baby one. All right, I'll see you guys shortly. Have a great day. Peace out.